GRE problem 1. Train A leaves New York at 7 a.m. traveling 80 miles an hour towards Boston. Train B leaves Boston at 7:45 a.m. traveling to New York at 70 miles an hour on a parallel track. If the distance between New York and Boston along the tracks is 210 miles, at what time will the two trains pass each other? There are two methods to solve this. The first method is distance equals time times rate. So we're going to write the formula down here, as well as our knowns. Train A is traveling 80 miles an hour. Train B is traveling 70 miles per hour. Train D is the distance is 210 miles between the two tracks. So the first method is we need to find out how far train A traveled before train B started, so that we know the distance between the two trains when they are both moving. So we know the distance is 210 miles total, but we have to subtract the initial distance that train A traveled prior to train B starting. We know that train A is traveling at 80 miles per hour, and we're going to multiply that by 0.75. 0.75, or 3/4 of an hour, or 45 minutes. So 3/4 of an hour, 45 minutes, or 0.75. So now we know that train A traveled 60 miles prior to train B starting, which means when train B initially started at 7:45 a.m., there was only 150 miles between the two trains, because train A had already traveled 45 minutes, 3/4 of an hour, or 60 miles. Now that we know the distance, we can plug this distance into our time and rate formula. So we know the distance is 150 miles. We know that time and rate, so we know the rate of train A is 80 miles an hour, plus train B is 70 miles an hour. We have 150 miles. 80 plus 70 is 150 times the time, which we're trying to find. How long did the trains travel? By manipulating the formula, basically dividing both sides by 150, you get time equals 1 hour. So this means that train B traveled 1 hour and train A traveled 1 hour during this 150 miles before they passed. But remember that train A had already been traveling 45 minutes. So if we plug this in, train A left at 8 a.m. 7 a.m. We know it had already been traveling 45 minutes, and we're adding 1 hour, because that's how long the trains travel between this 150 miles. So we end up with a time of 8:45 a.m. The same with train B. If If you add 1 hour to the 7:45, you end up with 8:45 a.m. 8:45 a.m. is when the two trains pass each other on the parallel tracks, with train A traveling 1 hour and 45 minutes total, train B traveling 1 hour total. Okay, the second method for solving this using the exact same formula is, we know distance is time times rate. The total distance was 210 miles. Train A is traveling at 80 miles per hour. Train B is traveling at 70 miles an hour, but started 45 minutes later. Remember, 3/4 of an hour is the same as 45 minutes, is the same as 0.75. So, what we're going to do is we're going to take this out. So we have 210 equals 80, train A, plus 70 minus 52.5. If we add 52.5 to both sides, we end up with 262.5 equals, we can combine like terms, 150t. So, divide both sides by 150, and you get t equals 1.75. Now this says that train A has been traveling 1.75 hours before it meets train B. If you remember, in the first method we took out the 45-minute previous jump. This one does not. So this is train A. If you add 1.75 hours to 7 a.m., you get 8:45. Now, we have to subtract 0.75 from the time for train B. You subtract it, you get 1 hour. You add it to the 0.75 or 7:45, and you come up with 8:45 for train B. So both methods will get you the same answer. Method 2 does not take into the account the distance traveled, but it takes into account the minutes. Where method 1 took out the distance of train 1 and then figured out the difference between the two trains traveling simultaneously.